Something strange happened in a quiet laboratory on Earth, something that challenges everything we thought we knew about reality. A single photon, the tiniest particle of light, was fired through a carefully crafted quantum experiment. What happened next was not just surprising, it was mind-bending. The photon appeared to split into two paths at once, as if it existed in multiple realities simultaneously. Even more incredible? The entire event was caught on camera. This wasn't science fiction. This was real. What we witnessed wasn't just a new discovery. It may be the beginning of a new understanding of the universe itself. Could one photon reveal the hidden structure of reality? Could this small experiment change how we see space, time, and even ourselves? In this video, we'll explore the experiment that shocked physicists, the eerie footage that defies common sense, and how this moment may connect to deep questions about the fabric of the cosmos and our place within it. Light has always been one of the purest messengers of the cosmos. From the glow of distant stars to the flicker of galaxies billions of light-years away, photons carry the stories of the universe across unimaginable distances. But in 2025, a group of researchers turned their attention not to the stars, but to the photon itself, to the smallest unit of light, hoping to answer one of science's most puzzling questions. Can a single particle truly exist in two places at once? At the heart of this mystery lies the Mach-Zehnder interferometer, a delicate instrument that splits and recombines beams of light. It's been used for decades in quantum experiments, but this time, something different happened. During a routine run of the setup, the team recorded a photon doing something it had never been seen doing so clearly before. It behaved as if it had split into two parallel versions of itself, traveling down separate paths and arriving at two detectors, as if it defied the rules of cause and effect. It was more than just a wave-like interference pattern. It was captured in real time. The lab, tucked away in Europe's quantum research corridor, became the center of international attention overnight. What made this so extraordinary wasn't just the outcome, it was the clarity. For the first time, ever, we had visual confirmation of a quantum phenomenon that until now was mostly theoretical, not a simulation, not inferred data, but video proof of reality breaking into pieces and reassembling itself before our eyes. Imagine the photon as a tiny traveler standing at a fork in the road, except instead of choosing one path, it somehow takes both at the same time. This is the essence of quantum mechanics, the strange rules that govern the smallest building blocks of our universe. Usually, particles like photons behave like little bullets, traveling one path or another. But under certain conditions, they act like waves, spreading out and exploring all possible routes simultaneously. This dual nature is called wave-particle duality, and it has puzzled scientists for over a century. In the experiment, the photon was sent through the Mach-Zehnder interferometer, a device designed to split a beam of light into two separate paths and then recombine them. Think of it like a cosmic traffic intersection with invisible detours that only the photon can see. When the two paths reunite, the photon's wave nature causes interference, like ripples on a pond overlapping and creating patterns of light and dark. What stunned the scientists was that the camera showed the photon hitting two detectors at once, almost as if it had cloned itself temporarily. This isn't just a curious trick. It suggests that reality at the quantum level is far stranger than our everyday experience. It hints that particles don't have a definite position until they're observed, existing instead in a blur of probabilities. This strange behavior is a glimpse into the quantum fabric that underlies everything, including the stars, planets, and even us. Understanding this phenomenon isn't just academic. It's at the core of cutting-edge science, including quantum computing, which could revolutionize technology by harnessing these multiple states at once. And it connects to some of the most powerful tools in astronomy, like the Hubble Space Telescope and gravitational wave observatories, which observe cosmic events that also challenge our understanding of reality. If photons can split reality itself, what does that mean for the larger cosmos? Could these quantum effects influence the life cycle of stars, or the way black holes warp space-time? The boundaries between the very small and the very large are beginning to blur, hinting at mysteries that may reshape how we understand the universe's ultimate fate. Though this experiment happened right here on Earth, the implications stretch far beyond our planet and into the deep timeline of the cosmos. When we talk about cosmic events, time takes on a different meaning. Many of the spectacular explosions and transformations we observe happen thousands or even millions of years ago. We're simply seeing their light reach us now. That's because light travels at a finite speed, and the universe's vast distances stretch our view across time. If a similar quantum event were to occur around a distant star or inside a collapsing stellar core, the effects might already be unfolding, even if we won't witness them for decades or centuries. Imagine a star in a neighboring galaxy suddenly behaving in a way that signals a shift in its life cycle, perhaps heading toward a dramatic explosion. When that happens, it could unleash a burst of energy so bright it rivals the full moon, lighting up the night sky and maybe even shining through daylight hours. Astronomers use an array of tools, from powerful space telescopes like Hubble to neutrino detectors buried deep underground and gravitational wave observatories listening for ripples in space-time, to catch these cosmic signals as soon as they arrive. We may not know exactly when or where the next big event will occur, but when it does, it promises to be one of the most breathtaking cosmic displays ever recorded. In the coming decades, our growing understanding of quantum phenomena and stellar behavior could converge, revealing explosions and cosmic shifts that will change everything we thought we knew about the universe's rhythm and fate. Imagine stepping outside one clear night and looking up to see a brilliant, blazing light suddenly appear where there was once only darkness. This light wouldn't be like any ordinary star. It would glow with the intensity of a billion suns, brighter than anything we've ever seen in our skies. For days, maybe weeks, this cosmic beacon would dominate the heavens, visible even in daylight, casting an eerie, silvery glow across the landscape. The explosion would unfold like a cosmic fireworks show, waves of shimmering light radiating outward, painting the sky with colors that no artist could capture. From every corner of Earth, people would witness this breathtaking spectacle, uniting us all in wonder and awe. Telescopes around the world would zoom in to capture every detail, revealing new clues about the universe's deepest mysteries. But beyond the stunning visuals lies an emotional weight. This wouldn't just be a pretty show, it could be a once-in-a-civilization event, a cosmic milestone that changes how we understand our place in the universe. For the first time, humanity would directly witness quantum realities playing out on a stellar scale, a reminder of how fragile yet interconnected we truly are. As the light slowly fades, leaving us with new questions and new hope, we'd be reminded that the universe is alive with wonders just waiting to be uncovered. Moments like these redefine our story and inspire generations to look up with curiosity, courage, and awe. Events like this quantum-driven explosion aren't just spectacular light shows. They are cosmic forges where the very building blocks of our world are created. When massive stars reach the end of their lives, they explode in violent supernovae, forging heavy elements like gold, platinum, and uranium deep within their cores. These elements are then scattered across space, seeding future generations of stars, planets, and even life itself. In a very real way, the atoms inside us, the iron in our blood, the calcium in our bones, were born in stars just like the ones we're watching now. This discovery is a goldmine for science because it connects the quantum realm with the grand cycles of cosmic creation. Understanding how particles behave on the tiniest scales helps us grasp how stars live and die on the largest. Stars such as Antares, a red supergiant over 700 times larger than our Sun, and VY Canis Majoris, one of the biggest stars ever observed, are prime examples of celestial giants whose explosive deaths enrich the galaxy with these precious elements. By studying these phenomena, we're piecing together the story of cosmic recycling, how energy and matter flow through the universe, constantly transforming and renewing. It's a reminder that we're not separate from the cosmos. We're part of an ongoing cycle of birth, death, and rebirth on an epic scale. Every star, every explosion, every photon carries a chapter of that story, and this breakthrough brings us one step closer to understanding our cosmic origins in a deeper, more connected way. Despite the awe-inspiring power of these cosmic explosions, there's no need for us to worry. Earth is safely tucked far away from any immediate danger. Even the most massive supernovae happen many light years away, and their energy spreads out across space, becoming harmless by the time it reaches us. What we might notice are beautiful side effects, like shimmering auroras dancing farther from the poles than usual, caused by increased ionization in our atmosphere. Natural light shows that remind us of the universe's power without posing any threat. Thanks to advanced neutrino detectors buried deep underground around the world, scientists can often detect the invisible particles these explosions release long before their light reaches us. This gives astronomers an early warning system, a kind of cosmic alert that lets us prepare and study the event in real time. So, while these spectacular events remind us of the universe's grandeur and sometimes violent nature, they also highlight how well-equipped we are to observe and understand them, safely and with wonder. We're witnessing the final breath of a giant, a farewell millions of years in the making. In that single photon, in that fleeting moment caught on camera, lies a story far bigger than us. It's a story of time and space intertwined, of particles and stars dancing together in a cosmic ballet that stretches across the vastness of the universe. This explosion is not just an end. It's a beginning, a reminder that the universe is alive, constantly changing, and filled with mysteries waiting to be uncovered. As we stand beneath this infinite sky, we are connected to everything that has come before and everything yet to come. Each flicker of light, each distant explosion, carries the echoes of ancient stars and the seeds of new worlds. It's a humbling thought, one that invites us to keep looking up, to stay curious, and to embrace the wonder of the cosmos. The universe is not silent. It's speaking to us in photons, in waves, in bursts of light and shadow, and as long as we listen, there will always be new stories to tell, new discoveries to make, and new reasons to dream. So, let's continue this journey together, toward the unknown, toward the extraordinary, toward the infinite. If you found this story fascinating, don't forget to like, subscribe, and share your thoughts in the comments below. Your support helps us bring more cosmic mysteries to light, so let's keep exploring the universe together.